Let us solve some problems using z finding the z transform of a given sequence using properties. Now, first question is, find the z transform of the signal x of n is equal to u of n, u of minus n. So we now given x of n is equal to u of minus n, we know that z transform of u of n is the 1 by 1 minus z inverse, or general we can use either we can represent the whatever the signal is there in z inverse or z, whichever is convenient for you. So we'll follow z by z minus 1, that is convenient for me, and you can use anything. Only thing, wherever z is there, wherever z inverse is there, you replace z, or wherever z is there, replace by z inverse. Now u of n is z by z minus 1, ROC is mod z greater than 1. Now here we want this is u of n, we want u of minus n, which is nothing but x of n. So if we use the time reverse property, that is, if x of n z transform is x of z, let us assume that x of s is a given function whose z transform is x of z, then x of minus n z transform will be x of 1 by z. So where ROC changes by 1 by r. Now if you compare this one, x of n is something like u of n, and z by z minus 1 is nothing but x of z, x of minus is nothing but u of minus n, right? Therefore u of minus n is wherever z is there in this expression, replaced by 1 by z. So 1 by z minus 1. Now even ROC, wherever here ROC 1 by z is there, replaced by 1 by z. Now the ROC will become mod z less than 1. What is the difference between u of n and u of minus n is both here, whatever the function you get 1 by z, wherever u z is there, you replace 1 by z minus 1. So here 1 by 1 minus z, mod z less than 1. Here what is the difference? Here is mod z greater than 1, here mod z less than 1. So this lies within the unit circle, this lies outside the unit circle. So this is the way we have to solve the given z transform using properties. If the question is asked particularly, you have to use the properties only, then you have to use properties only. Now let us solve the another problem. Find the z transform of the signal x of n is equal to 3 times u 2 raised to n u of minus n using the appropriate properties. So now we have to represent this one. If you observe this one, you have u of minus n. So we want time reverse. Then u of 2 raised to n. Then we want scaling. Now what we do, can we write 2 raised to n as 1 by 2 raised to minus n. So we are writing like this. What is the advantage of using like this? If you see, after writing 1 by 2 u of n, I can directly reverse the signal. Now we know the scaling property. Suppose x of n is given x of z, then a raised to n x of z. So now let us take we know that u of n is equal to z by z minus 1 for mod z greater than 1. Now we'll use scaling property. Instead of a raised to n, we have 1 by 2 whole raised to n. Instead of a raised to n, we have 1 by 2 whole raised to n. So scaling will be wherever z is there, replaced by z by a here. Therefore here z by 1 by 2. So simplifying this one, we'll get 2z by 2. So even the here ROC. So even ROC will be 1 by 2 into z is greater than 1. So this is 1 by 2 greater than 1 by 2. So here z divided by 1 by 2 is greater than 1. Therefore z is greater than 1 by 2. So this is the, now we'll apply time reverse to this one. So what happens, wherever n is there, you have to replace by minus n in here. Then here it will be wherever z is there, you have to replace by 1 by z. This is the time reverse property. So using time reverse property 1 by 2, so we are using 1 by 2. Wherever n is there, replaced by minus n. 1 by 2 whole raised to n u of minus n. Z transform will be wherever z is there, replaced by 1. 2 by 1 by z, wherever z is. Now even z, whatever the z is there in the ROC also, you replace by 1 by z. So z is less than 2. So rearranging these terms and getting z. So now simplifying this one, we got 2 by 2 minus z. But what else is there in the question? What else is there in the question? 1 by 2 whole raised to minus n, u of minus 3. So you have a 3 here. So multiply 3, which is a constant or linearity property. So apply using linearity property, whatever the function is there here. In 5 minutes. We'll add and subtract 3 here. Then this plus 3 will take outside and minus 3. Now it is x of n is equal to 1 by 2 whole raised to 3 n square 1 by 2 whole raised to n minus 3 u of n minus 3. Now using the scaling property, 1 by 2 whole raised to n u of n will be, already we have solved it, 2z by 2z minus 1 mod z greater than equal to 1 by 2 using time shift property. Here we have using time shift property. What is the time shift property says? If x of n, z transform is f x of z with ROC r, and shifted version of x of n will be how much you are shifting, z raised to minus n naught x of z, and ROC will not change if you are shifting the signal. Even you are differentiating, or if you are multiplying with n or differentiating z domain also, ROC will not change. So now we'll shift this signal. Now we'll shift this signal by n minus 3. So what does it happen? Just let us see. So it has to be multiplied z raised to minus 3. So 1 by 2 whole raised to n minus 3 u of n minus 3. Z transform will be, we have got 1 by 2 whole raised to u of n as z by z, 2z by 2z minus 1. Now multiplied with z raised to minus n naught. Minus n naught here it is nothing but 3. So minus n naught is 3, therefore minus n naught. Here ROC will not change, therefore mod z is greater than equal to 1 by 2. Simplifying this one and rearranging the terms, we get 2 by 2 z cube minus z square mod z greater than 1 by 2. But here the problem, here again you have what else you have in the problem? You also have here 1 by 2 whole raised to 1 by 2 whole raised to n here. Now this is our 1 by 2 whole raised to, this much part we have covered. Now we have to do n square. So to get 1 n we have to differentiate 1 2 times. So we have to differentiate the expression twice. First differentiate, whatever the answer you get, again differentiate and multiply with z. Then after at the end multiply with 1 by 3 whole raised to n. So here using differentiation property, n into 1 by 3 1 by 2 whole raised to n minus 3 of n minus 3 minus z into x of z, minus z into x of z. Simplifying this one, differentiating and multiplying with minus z, we get 6z cube minus 2z square by 2z square z cube minus z square whole square, and ROC will not change. ROC, if you see here, ROC will be not changing. First shift also for differentiation. Now I want n square. So again, whatever the answer you got, one more time you have to differentiate. So this minus z into this, whatever you got, you are differentiating. Again differentiate this one, and this 2 whatever is there, I got this 2. We are simplifying by multiplying by 2, dividing by 2 on both sides, numerator and denominator. Now at the end, multiplying with 1 by 8 or 1 by 2 whole raised to 3, so that you multiply with the whatever the answer you have, that is nothing but multiply by 3. Now we'll find the z transform of the signal x of n is equal to 1 by 2 whole raised to n u of n convoluted with 1 by 3 whole raised to n u of n. So we'll solve these problems in parts. One is nothing but whatever this first part is there of the convolution will take x1 of n, and the second half will take of x2 of n. Now x of n is equal to x1 of n convoluted with x2 of n. So in z transform, what does it happens? So if you apply z transform, it will be x of z is equal to x1 of z into x2 of z, because convolution in time domain will become multiplication in frequency domain. That's why x of n the z transform is x of z, x1 of z transform is x1 of n z transform is x1 of z. Here convolution will become multiplication, x2 of n z transform will be x2 of z. So x1 of z is nothing but you have x1 of n, you have x1 of is 1 by 2 whole raised to n u of n. So whose z transform is z by 2, z by 2, z by 2 whole divided by z by 2 minus 1 mod z greater than 1 by 2. And even x of x2 of n is 1 by 3 whole raised to n u of n. So z transform of x2 of z is z by 3, z by 3 minus 1 mod z greater than or equal to 1 by 3. So now z transform of this convolution will become multiplication. So you can further simplify this one. You can leave your answer here, or further you can simplify. Now this z into z will become z square by 2 into 3 will be 6 divided by z minus 2 divided by 2 and z minus 3 divided by 3. So it will be z 6 and 6 get cancelled in the denominator. You will have z square by z minus 2 into z minus 3. So the answer will become z square divided by z minus 2 into z minus 3 for mod z greater than 1 by 2. Why the here if you see ROC, if you see ROC of the first function is it is z point as 1 by 2 is nothing but 0.5, so it is greater than 0.5, and for for the second function it is 1 by 3 greater than, so common signal will be greater than 1 by 2. Therefore it will be ROC will be mod z greater than 1 by 2. So common signal you have to take, one is 1 by 2 and one is 0.3. So greater than 1 by 2 and greater than 0.3. So z is greater than 1 by 2 is the common signal you have.